Okay, and welcome to your tutorial on linear equations with pronumerals on one side. Today we are going to have a look at equations. It's our first lesson on equations, and we are going to look at exactly what they are, what we do, and how we solve them. For the moment, we are going to look at equations with pronumerals on just the one side. This should be a revision for most of you from last year. I've got a picture here. It's not a creative one today. It's a picture of a scale. There's a reason why I put a picture of a scale on here, and I'm going to come back to that idea in a minute. So let's start. What can we do today? Cool. What is it? What are we going to look at today? We're going to look at equations, and you need to write this down. An equation is a mathematical statement containing an equal sign, a left-hand side and a right-hand side. That is a really key idea. So far, we've just looked at expressions. We've just looked at statements. Okay, so 2x plus 4x. There's no equal sign in that. There's no left-hand side and no right-hand side. That's why we call those expressions. There is a difference between an equation and an expression. Equation has an equal sign in the middle. Okay? To solve an equation, this is a key idea. We need to find the value of the pronumeral within it. So to solve an equation, we need to find the value of the pronumeral within the equation. Before we begin, we are just going to have a look at a few key concepts which will help you for this tutorial. Okay, I talk about the idea that to solve an equation, we need to find the value of the pronumeral, okay? And if you guys remember this from last year in Year 7, you'll know we talk about this weird thing called inverse operations. In order to unpack an equation, what I do is I try and take away everything that is around the pronumeral. So if I have x plus 3 equals 7, I'm trying to take the 3 away from it. I'm trying to take everything away so I can just find what the x is, okay? It's pretty much like that. How do I take things away? Few key ideas to remember is if I'm trying to take something away from it, so say it was, for example, x plus 3 equals 6, okay? X plus 3 equals 6. The guy I'm trying to find is the x. I need to get this 3 away from it. I get the 3 away from it by subtracting 3 from both sides. I do my inverse operation. So in the equation, it says 3 plus, so x plus 3 equals 6. I'm trying to get rid of the 3. It is a plus. Therefore, I will use my inverse operation of subtraction. If, on the other hand, it said, let's say, ooh, I've lost my red guy. Okay, if it said 2x equals 6, okay, the operation that's going on there is multiplication. We've learnt about that. In order to get that x by itself, I have to do the opposite of multiplication, or the inverse. The inverse of multiplication is division. If you want to look at the big picture, basically I'm saying if I have, in this example, 2 lots of something equals 6, I need to find what one lot is. So I simply divide it by 2. Okay, so I would simply getting this 2x and dividing it by 2 to find out what x is by itself. I am engaged in the inverse operation. The inverse, or the opposite. That's a key idea, okay? The other key idea is that when I'm trying to unpack an equation, I try and take the thing furthest away from my pronumeral. So say I have 2x plus 3 equals 12. Here's my pronumeral. Here's little x, okay? And I know I'm doing inverse operations, but I don't touch this 2. I don't divide both sides by 2 just yet because I need to deal with the thing furthest away from the x. In this case, the thing furthest away from the x is my positive 3 here, or my add 3. I must deal with the thing furthest away. I like to think of it like, I don't know, a giant pile of books, and underneath it is your iPhone, okay? In order to get to your iPhone, you don't just take away the books that are right on top of it, you can't get to them yet. You have to take away the things furthest away. Imagine like a big pile in the middle of the room, like I was the worst teacher of all time, and when I confiscated your phone, I put it under a giant pile of books. You take away the books on the top, the thing furthest away from the phone, and then you slowly make your way down, getting closer and closer to your phone until you can finally reach it. Think about it like that, the thing furthest away, and then we work your way in. Hopefully that will give you a bit of an understanding of how to do it. This tutorial is going to work with 6 different examples. So now I need you to actually write each and every example and the exact way I work it out underneath this writing you've written so far in your rule books. Okay, so let's begin. So let's look at our first example here. It says 2x plus 3 equals 4. First thing I do is I'm going to underline my pronumeral. It's the x. That's what I'm trying to find. I like to think of equations like a set of scales. If I take away something from my left-hand side, I have to take away from the right-hand side. If I want to add something to the left-hand side, I have to add it from the right-hand side. I'm trying to look for x, okay? In order to find x, I have to take away things that are around it, okay? So, let's have a look at this example. I've got 2x plus 3 equals 4. First thing I'm going to do is I'm going to take the 3 away from the 2x. So I'm going to take the 3 away there. Okay, so positive 3. Oh, sorry. I've written it above it. It doesn't matter if you write it above or below or next to. I just wrote it above because I didn't have any room. Equations are like scales. Equations are like scales. What I do to one side, I must do the same thing to the other side in order to keep my scales balanced. Okay, so if I take away 3 from this side, because it's 2x plus 3, I need to take that 3 away. I must also take the 3 away from the other side. So 2x is equal to 1. Okay, because I've taken the 3 away from this side, so they've cancelled each other out. And then 4 subtract 3 is 1. Now that's saying 2 of x is 1, or 2 multiplied by x. In order to get x by itself, I have to do, like I did with the subtract 3 plus 3, the opposite operation. The opposite operation of multiplication is division. So I divide that side by 2, and I divide that side by 2. Now, 1 divided by 2 is a half, as it is written here. So x becomes a half. Now, this is the cool thing about equations. I've got my answer, a half. I can actually substitute it in to make sure it works. 2 multiplied by a half, add 3, is equal to 4. What's 2 multiplied by a half? A half plus another half is a whole, plus 3 equals 4. Does 1 plus 3 equal 4? 4 and 4? Excellent. Okay, I've substituted in, which means that if both sides of my equation match, no matter what the number, in this case it was 4, okay, if the left-hand side is equivalent to the right-hand side, then I've correctly solved my equation, okay? So that's a way we can check afterwards. Let's have a look at another example. Okay, x divided by 4 subtract 3 is 7. X divided by 4 subtract 3 is equal to 7. So just like before when I was showing you guys, the really important thing to pay attention to here is I take away the things furthest away from the x, okay? So I can't multiply both sides by 4, even though it's x divided by 4, because there's still things further away. I start from the furthest thing away. So x divided by 4 subtract 3 is equivalent to 7. So if x divided by 4 subtract 3 is 7, I think what I'm going to do in order to try and find the x is add 3 to this side and add 3 to this side. So it becomes x divided by 4 equals 10. Because I use the inverse operations, okay? So if it's x divided by 4 subtract 3, I need to get that back to 0. Negative 3 plus 3, 0. That works for me. X divided by 4 is 10. Now x divided by 4 is 10. I need to find x by itself. Therefore, x divided by 4 multiplied by 4 equals 10 multiplied by 4. Sorry, this has turned out to be a bit dodgy. Okay. Let me write that better for you. Come on. Okay, my rubber tool's a bit dodgy and I've missed some. Yes, Reese, I've missed some. Okay, anyway, that's the best I can do. Okay, so x divided by 4 equals 10. Okay, I'm going to multiply this side by 4, which will cancel out that division, and multiply this side by 4. Okay, therefore x becomes 40. And it's as simple as that, guys. So I can see if I'm right, okay? Let's try substituting. Let's do it quickly in my head. I've come out with x equals 40. That's my answer. So 40 divided by 4, subtract 3 equals 7. What I'm wanting to see here is that this side is equal to this side. Okay, so I'm hoping that my left-hand side is going to equal 7 at some point. 40 divided by 4 is 10. 10 subtract 3 is 7. 7 equals 7. Excellent. I've solved my equation correctly. Okay, let's look at the next example. 5 subtract 2x is equivalent to 12. 5, a different coloured pen. 5 subtract 2x is equivalent to 12. I need to take the 5 away first. Okay, so 5 subtract 2x. 5 subtract 2x. Okay, I will take 5x away from this side. Why am I taking 5x away from this side? Is because 5's a positive number here. I know it's a positive because it doesn't have anything before it. And I take away 5 from there. So it becomes negative 2x. Remember, the negative sign belongs to the 2x. Negative 2x equals 12 subtract 5, 7. Okay? Negative 2x is equivalent to 7. Let's move that up there. Negative 2x is equivalent to 7. Therefore, x is equivalent to... Oh, actually, I've taken it a step too far for you, okay? Therefore, negative 2x divided by negative 2 equals 7 divided by negative 2. Okay? So, my answer becomes x equals 7 on negative 2. Now, that looks a little bit dodgy. Okay, 7 divided by negative 2. Well, 7 divided by 2 is 3.5. So 7 divided by negative 2 becomes negative 3.5. Okay, and it is as simple as that, guys. The other way you can show that if you'd like, if you want to convert your improper fraction to a mixed numeral, is negative 2 goes, 2 goes into 7 3 times, remainder 1 on 2, and it's a negative because there's two negatives, a negative and a positive, so my signs are different. Again, I'm racing through this, so you might want to stop, write it down, go back and have a look. Okay, let's look at the next example. I've got 2x divided by 3 plus 5 equals 7. So what I'm attempting to do here is I'm attempting to take away the things furthest away from the x, or furthest away from my pronumerals. That would be the 5 here. Subtract 5 from this side, subtract 5 from that side. My answer becomes 2x divided by 3 equals 2. Okay, 2x divided by 3 is 2. 2 of something I don't know divided by 3 is equal to 2. Let's put this guy up here. Okay, 2 divided by... Oh, sorry, I didn't mean to rub that x out. Okay, that x is still meant to be there. 2x divided by 3 multiplied by 3 is 2 multiplied by 3. Why have I multiplied? Because here I am dividing. In order to cancel out that division, divided by, multiplied by, cancels it out. What I do to one side, I must do the same to the other. So 2x is equal to 6. 2x divided by 2 is equivalent to 6 divided by 2. X equals 3. Let's go back and have a look what I did there. 2x is equal to 6. 2 lots of something I don't know is equal to 6. If 2 lots of it are equal to 6, I need to find out what 1 lot of it is. So I divide. I do my opposite or my inverse operations. 6 divided by 2 is 3. x equals 3. That's my answer. Okay, next little guy. This is an important one to pay attention to. 2x add 4 divided by 9 equals 2. That, my fine young friends, is saying all of this, that whole entire statement, divided by 9 is equivalent to 2. 2x plus 4, all of that divided by 9 is equivalent to 2. You cannot separate the top line from the bottom line just yet. If you were sitting there thinking, oh, the first thing I'd do would be subtract 4 from each side, wrong. You do not subtract 4 because it is all of that divided by 9. So the first thing I need to get rid of is my 9. So I multiply this side by 9 and this side by 9. Okay, and my answer becomes 2x plus 4 equals 2 9s are 18. Now it's a little bit more straightforward. So 2x plus 4, subtract 4 from that side, it's equivalent to 18, subtract 4 from that side, 2x equals 14. Should be able to do this in your head now, guys. 2x divided by 2, 14 divided by 2. Again, what I'm doing here is I'm saying 2 lots of x. I need to find 1 lot of x. 14 divided by 2 is 7. Main lesson from this one. All of that divided by the bottom. That's what that's saying. You cannot separate the plus 4 just yet because it is that whole statement divided by 9 equals 2. Okay, let's look at this guy. Cool, I like this one. This one's an awesome example because this is where most people get confused. 10 equals 5 plus 2x on 3. It looks weird. Why does it look weird? Because commonly I'd have the 10 on the right and the other side on the left. It doesn't matter what way I write it. All I'm saying is one side is equal to another side. That's all I'm doing. One side is equal to another side. One side is equal to another side. That is all I am saying, okay? So, what you can do if it makes you feel a little bit more happy is 5 plus 2x divided by 3 equals 10, okay? You can write it like that. That's fine. You can flip the sides around. Then it looks a little bit more straightforward. So, all I would do is I would subtract 5 from this side, subtract 5 from that side. Then it becomes 2x on 3 equals 5. Multiply this side by 3 to get rid of the 3. I'm skipping lines now, guys. Again, one under the other. So that becomes 2x is equivalent to 15. X, I'm going to skip the last step. You guys can do that. If 2x is 15, x is half of 15, which is 7.5. Okay? That was done really quickly, guys. Main thing to pay attention to, main idea here was that this is equivalent to this. Doesn't matter which way I write it. If it helps you to flip it around, flip it around.